I'll go ahead and introduce our next speakers. That is Kenneth VanBik and Honeiah Karimi, who are presenting a presentation, computational reconstruction of Proto-Central-Chin tones. So a round of applause for our presenters, and you're already sharing your screen, so that's great. Go ahead and get started whenever you like.
All right, so I hope you can hear me. So I'm Ken, and I'm very happy to be here. I feel like strange dressed up in my own room. So, but I did. Okay, so we're very happy to present this computational reconstruction of Proto-Central-Chin with my colleague Honeiah Karimi. And so here's our roadmap for our presentation. Um, the next slide. Okay, so I'm going to talk about until the first two, and from data to conclusion, my colleague will take over. And so I think our presentation is about 20 minutes. So we are looking at the reconstruction of Proto-Central-Chin tones for live syllables, by which we mean we have, CVV, CVR, or CVVR, R as in like sonorants, based on 3 core Central Chin languages. As we will show in Peterson 2007, we have Mizo, Flam Chin, and Hakhalai for that. And Mizo and Flam Chin has 4 tones, and Hakhalai has 3 tones. So here is Peterson 2017, the newest subgrouping in our branch. So he has something like Northwestern, so usually known as old cookies, like Monsang, Lamkang, Chiru, and things like that. And he has Central, and he has 2 groups in Central, the core Central, that includes our presentation languages today, and also Maraic. So I would just want to note that in my reconstruction, Maraic was the separate branch in this family. And we have peripheral, that we have northeastern, and that include like Didim and things like that. And we have southern, and we also have Comic. So this newest subgrouping is sort of like trying to be very geographical terms. I think this is a good further development in the Kuki-Chin branch. All right, so I just want to introduce how tone markings are done in Kuki-Chin languages. So Mizo, also known as Luche, is one of the most studied Kuki-Chin languages. And it was actually one of the pillar languages that Paul Benedict used in reconstructing the Proto-Tibetan Burman. And we also have very modern, sources for Mizo, Changte 1986 and 1999, and also Lorraine is that we mentioned. So this is the dictionary that has Lorraine make in 1940, and originally it wasn't marked. So the tongue were not marked in this book, and it has about 600 pages. And so there was a Mizo scholar, Mr. Shyamkima, who worked with Dr. Chris Lehman in marking the tongues. So they mark all the tongues of the entries of the history, the dictionary. And in the, so here is their notation in the black color, but the green and the blue color is kind of how I mark in when I enter them the tone, and so but we have low, rising, falling, and high. So I want to include this because I want to show that how hard Mr. Shyamkim worked in this, doing that. So it was done in Champaign, Illinois. It was finished in 1976. So he said, Azota. So he must have felt so relieved after marking all these, tones into the language and the dictionary. And there are a few copies of this. I got this from my advisor, Professor Jim Medisoff. And there are a few copies circling for this particular, tone mark dictionary. But most of them which I need are entered, into this paper. All right, so this is how the tone marks may be represented in Mizo. So we have Changte 1986 and 1993. So she has some with number and some with this real, tone mark. And then the way that is also represented in VanBik 2009. But in this paper, the way we represent is like high, low, rising, and falling. And the Falam Chin, also known as Zahao, Lizo, they were collected mainly for my dissertation. And I also speak some language by association because my wife is Falam. And we have the latest analysis of Falam tones in Khartoum 2008 from Payarp University. And so we have how we show the correspondence in table 2. And they are very consistent. So Khartoum has this tone marking with numbers. But we represent high, low, rise, and falling in this paper. All right, the last one I want to talk about is Hakalai. And in Hakalai tone, it is important to note the tone sandhi because especially for if you look at like 1A here, the rising tone is falling at the beginning of the sentence. So that is very important because it could be mistaken. And when we enter the tone of Hakalai, we consider, we are very careful about the rising tone. All right, so from now on, my colleague Honeiah will take over.
Hello, everyone. So for our tonal data, we had approximately 719 PCC edema in total, and these are gathered from VanBik 2009, and this established the cognate set of these 3 languages. We are dealing with categorical data since tones are defined by quality, not quantity. For a tonal category to be assigned at the PCC level, there must be cognates in at least 2 of the 3 languages. The significance of our computational reconstruction is that it adds a 5th proto-tonal category, PCC tone 5, in addition to the 4 tonal categories reconstructed in VanBik 2009. So for our methodology, we use Python, which is a high-level programming language. This just means that it's closer to natural human language when we compare it to low-level languages that are closer to machine language, such as binary. Python is frequently used for data science because it supports object-oriented programming. We specifically use Python 3.8, which is the most current version of the language. We use the open source Python distributor Anaconda because it offers the Python packages and libraries that we needed. Anaconda is the industry standard for data science. Within Anaconda, we use Jupyter Notebook to edit and run our code. We imported the open source Pandas library to read our data stored in Excel. In order to analyze the most common tone pairings, we use the collections library. Within the collections library, we use counter, which refers to a type of dictionary or an unordered type of data structure. The first step we took was reading our data. So the way that we did this is that we converted our .xlxs sheet, which is just a standard Excel spreadsheet, into a .csv or comma separated values file, and then we use the pandas library to read the data. We called our data sheet df for data frame. This is the variable we call to represent our entire data set. So because Python is case sensitive, we must just be consistent and use the lowercase d and f. So in single quotations, we write the file name. So you can see here, we have df is equal to pd for panda, .read csv, that's our file, and then the file name. And then we're gonna display df. So this is our output for our data frame. I couldn't fit all of it, so I did the first part and the last part. So what you can see here is that we have 719 rows because we have 719 edema, and Python starts counting at 0, so that's why at the bottom you see 718. And so this is the output for our data set. So now that we've read our data frame, we were able to finally investigate our data. First, we looked at the data using the count function to see how many tones we have in each of the 3 columns. This will be shown on the next slide. This is helpful for calculating the percentages of tones in each language and then the overall most common tone pairing. So here you can see the output of data frame, so df.count. And so as I said, we have 719 edema, but we can see that for Falam-Chin, we have 519. For Hakalai, we have 781, and for Mizo, we have 641. So what we wanted to do first was to look at 2 languages at a time and then do all 3 at the end. So we see here the output of our first count. We're going to see Falam-Chin on your left side and then Hakalai on the right side. So Falam-Chin with a rising tone and then Hakalai with a falling tone happens in 187 cases. Where you see NAN, that means not a number, so there's just no information in that specific cell. So the next one that we can see that's important here, that where we have 2 cognates, is that Falam-Chin, when it's a high tone, Hakalai has a falling tone, 95 cases. So next we looked at Falam-Chin and Mizo together. So here Falam-Chin is going to be on your left side and Mizo will be on your right side. So where Falam-Chin has a rising tone, Mizo has a high tone, and this happens in 180 cases. Where we find Falam-Chin has a high tone, Mizo has a rising tone in 98 cases, and so on and so forth. So the last, where we did the 2 languages at a time, here we have Hakalai on the left side and then Mizo on the right side. So where Hakalai has a falling tone and Mizo has a high tone, this happens in 238 cases. And then where Hakalai has a rising tone, Mizo has a low tone, this happens in 108 cases. And again, so on and so forth. So the last one that we want to look at is all 3 languages together. So here we find where Falam-Chin has a rising tone and then Hakalai has a falling tone, Mizo has a high tone. This happens in 159 cases. So this will actually be our tonal category 1 that we propose. The second one we find here is that Falam-Chin has a high tone, Hakalai has a falling, and then Mizo has a rising tone, and this happens in 73 cases. This will all be shown in a table shortly. So in order to verify our findings, we wanted to use a different method just to see the most common pairings, so the maximum count. So here we can see that our output, where it says Falam-Chin is rising, Hakalai is falling, and Mizo is high, that actually was what we saw was the most, maximum count there. So we find that, okay, there was no error in our code. So this is a table where we can see the tonal correspondences. So for category 1, we have Fulam-Chin with a high tone, Hakalai with falling, and Mizo with rising. For tonal category 2, we have Fulam-Chin falling, Hakalai rising, Mizo falling. Category 3, Fulam-Chin low, Hakalai rising, and Mizo low. Fourth, we have Fulam-Chin rising, Hakalai falling, Mizo high. And then we have the last one, tonal category 5, where Fulam-Chin is high, Hakalai is low, and Mizo is rising. So here we have the exact counts and percentages of our data. So for, this is all shown in appendices, and where we see for tonal category 1, 264, so this is going to count not just where we have words for all 3 languages, but also, if you remember, we mentioned earlier, they need to have at least 2 cognates. So that is counted here as well. And we were able to account for 588 of the total edema that we had. So for tonal category 1, 264 edema, that's actually 36.7% of the entire data set. So that's the 719 total that we had. However, if we want to just look at the counted data, so what we were able to account for, the 588, that's actually going to be 44.9% of that. For our second category, we have 135 edema. So this is 18.8% of the entire data set, and then 22.9% of that counted data. Category 3, we have 118 edema. That's going to be 16.4% of the entire data set, and then 20% of the counted data. For the fourth category, we have 46 edema, 6.4% of the entire data set, 7.8% of the counted data. And then tonal category 5, we have 37 edema, which is 5.2% of the entire data set, and then 6.3% of the counted data. And then appendix 6 shows all the ones that we couldn't account for. So as I said, we were able to account for 588 edema, which is 82.4% of the total data. The assigning of tonal cognates are based on frequency of tonal correspondences, that is the highest possible number of pairings for each category, and therefore the most likely tones for the ancestral language Proto-Central-Chin. In the future, it would be interesting to see how more data would impact the proposed tonal categories. And these are our references.
Wonderful. All right. Thank you very much for that presentation. I actually have about 13 minutes for questions if anybody has some questions that they'd like to ask. I'd like to indicate that in chat.
Can I ask a question?
Yes, you may.
I found this paper very exciting, and I'm wondering whether you, within each of your categories, whether you've looked at the initial consonant as a possible conditioning factor for perhaps a tonal split.
Yeah, hi, Jim. We haven't. So I think this is our first, the first step that we want to look at is like the strength of statistical correspondence. And then the reason why we come up with the 5th category is because we find that about 27 cognates. And so 27 cognates is too large a number to ignore. And the correspondence, I think, is very solid. So the initial, I think our next step, I think that's a really nice point that we need to go further, is that we should look at the initial consonant, and maybe even beyond Kuki-Chin. I don't.
Yeah, of course, it's very exciting, I think. Thanks for this.
Thank you, Jim. You want to add anything, Honeiah, to that?
You're muted if you'd like to unmute yourself.
Oh, sorry about that. I was just going to say that, yeah, I think that's a great question. And I agree that's something that we should look at in the future.
Right.
Additional questions? Plenty of time?
I have a question I'd like to ask.
Okay, please.
When you have reconstructed these different tonal categories of Proto-Central-Chin, they just have like numeral names. Do you have any information about what those particular tonemes were?
I was afraid that somebody would ask this. So it seemed to me, this is just only my intuition, that Phalam Phalam tones that has high, falling, rising, and low seem to be quite, that's only my intuition. So that would be what I would say look like the prototones. But what I would add with the fifth tone would be a mid-tone. So it will be, it will look like Phalam or Mizo with a mid-tone added to the proto-phoneme, toneme, like tonemes, right? Tonemes.
Thank you.
Sorry about that. Tyler actually has a question, I believe.
Yes. Hello, Ken. Good to see you.
Hi, Tyler.
Yeah. I just had a question because, as you know, I'm more familiar with the Northern Kuki-Chin languages. Do you not analyze Mizo, Phalam, or Hakalai having a glottal tone at all?
No, we haven't looked at the stop syllable. So we so
Oh, right. Yeah, of course.
yeah. So these are live syllables. So yeah. I don't know if I want to conflate the stop tones into this. If possible, I would like to analyze the stop tones a little bit different from the live tones, and I don't have any reason for that.
Yeah, sorry, I forgot the detail that you said it was live syllables only. So yeah, but I totally understand. It's good to analyze them separately from the live syllables.
Oh, thank you. I'm glad that you agree with this.
Thank you, Ken.
Mary actually typed out comments. Not sure if she wanted to read it, but I'll go ahead and read it. It says, thanks for the presentation. I'm wondering if you all had talked to Dr. Priyanko Sarma, who's been working on mesotone, and she just states that he may have more data for your future studies.
Yes. Also, if that is the case, I think I would like to see how they are marked, you know, and match with like the two-tone system, the two systems that we had in Mizo. You know, Dr. Changte, Lanun Tangi Changte, and also Lorraine. If they are different from that, I think we need to match. We need to match out the correspondences, just to make sure that we are on the same. Yeah. In order to do that, I think I would like to see the solid correspondence matching out. Yeah. Thank you for that suggestion.
Ken?
Yes, Jim.
Oh, what does azota mean? Thank God it's over or something like that?
Yes, thanks God. Yeah, it's finished. Just like Jesus said on the cross.
Uh-huh. Okay.
Right. any additional questions? So we still have actually about 5 more minutes.
Thank you for reading my comment from the chat. Yeah, I lost connectivity like right at that moment. So, but I heard a lot like the beginning of your answer, but yeah, making them comparable will be, it's hard to know whether you're talking about the same tone that you've marked, but yeah, so it may be a source for more data, but not sure.
Yeah, I think it will. I think it will be, but I'm sure if the tones are marked. But I think we have very solid, tone marking system and a lot of data. I mean, we have like 600 pages, data from Mr. Siamkima marking, and yeah.
Yeah, I think people have audio data though, rather than text.
Okay. Okay, we have another question. What must be the reason why the live tones of the three central chin are so different from each other? So, I think we are talking about tonogenesis here. So maybe that we go back to Jim's question, if we can have any tone split or tone emerging from based on the consonant of the onset of the word. So, well, I mean, so central chin tone. I mean, bomb has, according to my source, has 2 tones, and Tlang has 2 tones. Those are like mutually intelligible Lai dialects, and so why must they be different? They are different. Why must they be different? So I can answer that actually. Maybe tone merger, or maybe you might have an answer, Mr. Pao Tang.
So it's about 3 minutes actually. Presentation ended a couple of minutes early, so still time if anybody wants to add to that, additional comments or questions.
I wonder if you could move the references from the article from the screen, because it covers up a lot of things. Oh, there you go. Thanks.
So maybe I can ask my former advisor, Jim. So Jim, you think you are convinced that there could be a 5th tone that we can do? I mean, we can propose in this.
I don't know yet. I have to look
okay.
at the
Yeah.
data.
Okay.
But I think this is a great step forward, just getting the correspondences straight. That's indispensable for anything more we want to do.
Yes. And also, we provided all the list of the cognate sets as a handout.
Great.
So yes, so it is available. So we have tone 1, tone 2, tone 3, tone 4, tone 5, and then like appendix 6. So I think we have about 60. Honeiah, how many pages do we have? 60 pages of handout?
Is this on the conference website?
We sent it with our recording, so I don't know if it's on there.
Okay. Yeah, it's available. It's available. You remember the pages?
I think it was probably somewhere around there. Yeah, like 60 pages.
Okay. Yeah.
Great. Thanks.
Ken, I think that there may be some private messages for you in the chat with questions. If you don't mind checking the chat box.
How does final chorals and stuff figure in your comparison? So that is so we consider final chloral stop as a check tone, so we don't consider as part of our analysis. So any etymon that has final chloral stop they will be excluded.
Okay, that's about all the time that we have for this session. Let's give our presenters one more virtual round of applause. There's going to be, I believe, a 15-minute break after this, and then a special session starting at 6:15 local time, just about 15 minutes from now. So, yeah, thank you very much, everybody, and we'll see you there. Thanks again.
All right. Thank you.
Thank you all.
Yeah.
Thank you very much.
Bye-bye.
Bye.
All right.